A 100 kg of ice is kicked so that it will have an initial velocity of 10 meters per second. If the coefficient of friction between the horizontal floor and the ice is 0.10, compute the total distance that the ice block traveled before coming back to rest. And to solve this problem using kinetics, we can use the equation given the initial velocity, the acceleration, and the final velocity of the ice, that is Vs squared equals to Vi squared plus 2 times the acceleration multiplied by the displacement. So we have our final velocity, since it is coming back to rest, that is equal to 0, with an initial velocity of 10 meters per second raised to the power of 2 plus 2 times the acceleration, which we will solve later, multiplied by the distance d, which we want to solve. And to solve for the acceleration, that is due to the friction force from the surface, we use Newton's second law of motion, that is, force equals to mass times acceleration, where acceleration is equal to force, which is the force of friction, divided by the mass. And to solve for friction, that is basically equal to mu times the normal force of the ice to the surface, divided by the mass of the ice. So we have mu of 0.10 times the normal force of the block exerted on the surface, that is just equal to the weight of the block, that is equal to 100 kilograms times the gravitational acceleration of 9.81 divided by the mass of the ice of 100 kilograms. We get our acceleration equal to, now notice that these two values here cancel since they have the same magnitude, so we get A equals to 0.1 times 9.81, which is equal to 0.981 meters per second squared. Now we can solve for D. This is 0 equals to 10 meters per second raised to the second power plus 2 times the acceleration, since it is opposing the direction of motion, it's negative, that is 0.981 meters per second squared times the distance d, which we want to solve. We get d equal to 50.97 meters. Another way to solve this problem is by using the principle of the conservation of energy. That is, the initial energy must equal to the final energy of the body. So we have velocity, therefore this block here possesses a kinetic energy that is equal to 1/2 mv squared minus the work exerted by friction, that is equal to force times the distance d, equal to the final energy of the block, that is equal to 1/2 mass times its final velocity squared. Now we're given a mass of 100 kilograms and the initial velocity of 10 meters per second squared minus the frictional force of 0.1 times the weight of the body, that is equal to 100 kilograms times 9.81 meters per second squared times the distance that we need to solve, equal to 1/2 times the mass of 100 kilograms times the final velocity of 0, since it is coming to rest. Therefore this entire expression here is just 0. Now we can solve for d, equal to 1/2 times 100 times 10 squared minus 0.1 times 100 times 9.81 times d equal to 0. So solving, we get d equal to 50.97 meters, which is the same as we solved earlier.